Hi everyone, and welcome to another installment of a Pentera CyberPulse webinar. This time, I want to talk about, one of the biggest blind spots in your software development lifecycle, and those are your Git repositories. As you may have a conception or a notion of what these are and what they entail, but we like to think of them as not just another kind of version control. They're actually an open door to your CI/CD pipelines. But before we start, I'd like to introduce myself and my co-host in this session here with you. So my name is Asaf Regev. I'm the Director of Product Marketing at Pentera. I have over 20 years in cybersecurity, started in technical, but kind of moved on to more strategic roles. And today my focus, or our focus really is simple at Pentera. We're kind of here to help you prove and improve your cyber resilience over time. And I'd like to hand it over to you all to introduce yourself, and we'll kick it from there.
Thank you, Asaf. It's a pleasure to be here and talk about what we've done the past few months. My name is Or Smolnik. I'm a Senior Product Manager here in Pentera, mainly focused on the Surface, which is our external attack surface validation tool. And been here in Pentera for the last 3.5 years. Previously, I've been in many technical and cybersecurity companies, and it's a pleasure to be here again.
Excellent. So let's dive right in. So for today, as far as the roadmap, we've done the intros. Let's really speak of kind of the meat and potatoes of the presentation. So we'll start off by really exposing the hidden risks in your environment, and we'll see some examples. We'll give you kind of a rough highlight and understanding of where we see the market, but also look at some of the trends and and initiatives around it. We'll really dig into the what we like to call the attacker's perspective or the attacker's playbook, and oftentimes we kind of disregard some blatant things that are out there, and we would like to kind of point these out to you, obviously show you our approach, the Pentera approach, if you will, of kind of how we help to alleviate the problem or tackle the problem. Obviously show you some real examples, and hopefully kind of give you a head start before the next headline hits. So let's jump right into it. So if we have to kind of look at the overall market, and that's based on a number of conversations that both myself and Or have been having with with existing customers, but also prospects. And when we speak to them, there are three main topics that they kind of that as I said, customers and prospects kind of always talk about, and I'm wondering if this is something that you guys also see, and we'll be happy to kind of have that conversation. So as you kind of look through this, and we'll describe this, happy to get your feedback and your thoughts in the Q&A box, and try to make this interactive with us, because this is really a hot topic that we would like to cover. So the first one is limited visibility, and again, this is because of one or a few main issues, but probably the biggest one is they typically or kind of Git repositories typically sit outside of your IT knowledge. And that means that, you may have employees that are running side projects or personal forks or have temporary workspaces, but this is exactly the notion of where exactly attackers begin. And we've seen this in, if you look at the Verizon 2024 DBIR, 74% of the breaches basically involve a human error misconfiguration, and we'll see some example later on. The second is, again, you speak of the the exposure, but what does it actually mean? How do you know, or how do you know whether one of your employees, as we've said before, has accidentally or not committed code or history into a Git repositories? How do you know? Well, you may know this or you may not. So there are some issues there, and that basically creates this unknown exposure or a means for attackers to really get kind of a purview into this information. And again, based on information that we've seen from GitHub, over 39 million of these secrets have been leaked in 2024 alone. So the numbers are staggering. It's a massive issue. And I think the third one is probably the hardest, and the one that that we need to put really the focus on, and that's the context. So even when exposure is found, how does or how do your teams kind of know if it's exploitable? how do you know what the fallout might be should that information be out there? So let's really, get a better understanding and a closer look, at some examples and, kind of tie this in so you understand, what it really means. The first one, again, three main examples. The first one is, well, unfortunately, those are, two of the main ones are automotive related, but, but we've seen that happen across, a number of other breaches that occurred out there. But the first one, as you can see here, is Toyota. And here, I hate to say this, but, data that was left open for 5 years. And that's, just a staggering amount of time. 5 years, not 5 weeks, 5 years. This was the number of years that data was left, kind of public information or, my information. I own 2 Toyota cars. So just thinking about it, makes me, sick to my stomach. But just think of what would happen if my public information or my private information were to be stumbled upon by someone, because of an employee, kind of accidentally exposing this repository to the public. The second one, again, automotive related. This one here with Mercedes, was as a result of a GitHub token that exposed a large portion of their source code. So source code for car manufacturers, and we'll see that in in the example when we dive deeper. It can be anything from from car kind of plans, car blueprints. It can be anything that you can imagine. And we know that they're on the cutting edge. Mercedes is on the cutting edge of of hybrid, but also electric cars. So what happens if one of their not necessarily customers, but one of their competitors now has access to that data, and that's a friendly situation. But what happens if a disgruntled employee or any other now has full access to that to that repo? It's just crazy to think about it. And the downside is that it didn't happen because of a brute force. It didn't happen before, because of a breach. It was just, a set of credentials sitting in plain sight. And the last one, and we'll see that in the next slide, is kind of GitHub themselves. They basically reported, as we've said, 39 million leaked secrets in 2024 alone. It's a staggering number. And we've spoken about this before. And obviously, as I said, we are speaking to to the repercussions of something like this happening with our customers, with our prospects. What are they telling us? I mean, how are they kind of dealing with this kind of issue?
So let's take a minute for the 39 million. Okay, this is only what GitHub knows that were leaked. You know how many leaked credentials there are in the GitHub repositories that they don't find out? Probably a lot. And there are lots of measurements that customers can do, and GitHub themselves, to make sure that things like that won't happen, like what we see here, that GitHub will expand it to further analyze all the commits and all the what people will provide here. And security analysts and operators must have certain visibility to such items, to first of all, to understand what are the Git repositories that they have. They need to start with that. And we know, again, from talking with customers and prospects, they don't know that. They don't know how many accounts exist outside. They don't know how many Git repositories exist. And this is a crucial understanding that they first need to know.
Interesting. So let me so we said we'll jump into more details. So that slide pretty much puts everything in perspective. And those are numbers that have been, kind of exposed and spoken freely from GitHub. So if you think that it's only kind of a niche problem, think again, it's everywhere, it's growing. And the last kind of item proves that pretty much, straight up. So 90% of Fortune 100 companies rely on GitHub. So it's not, I mean, I wish it were the 10%, but that's not the case. And the numbers here are staggering. Over 250 million developers worldwide use it. It holds 5.2 billion contributions across 518 million projects. I mean, those numbers are staggering. I mean, when I first read this, I was like, that's interesting, but is the 39 million kind of exposed number that we've seen previously, is that the right number? And just like Or really mentioned, that's what, that's on the basis of what they know. But what happens to the other information that may sit there? They may not fall within the category of what constitutes, private information or secrets So that's, again, it's a massive pool of information. And as I said, it's not a niche problem. It's everywhere and it's growing. And it is really, it's a growing pain and it's a growing challenge for organizations, big and small. But, before we kind of continue, I'd like to kind of take a moment for everyone and do a bit of a pulse check. So what I want to do is, ask you a poll question. And the first one is this one. How confident are you in your organization's ability or visibility into exposed Git repositories? And here I'd like you to answer, the question. Again, feel free to not answer the question. It will be really interesting if you could. So I really want to see kind of the numbers, whether you feel very confident in your organization's visibility. The second is somewhat confident. The third is not confident at all. Or you may be one of those, happy people who says, listen, I don't consider this to be a problem at all. So I'll give you guys a couple of seconds and hopefully we'll get some information, back from you guys in terms of the poll itself.
Yeah, and I want to focus about the visibility of those, because there are tools like threat intelligence tools and other ones that their goal is to provide you this understanding, to provide you this whole situation of how many assets and how many Git repositories exist and can be exposed and can be used for attackers to be able to connect them and to view and to gather some interesting information about the company, about the product, about anything. And it's really important for the visibility aspects alone. This is the crucial ramp up from and step up from does not know what is exist out there, and to have a certain start for the understanding of the security, what we need to do, and how we can defend on those Git repositories.
So we are actually seeing, a bunch of your answers, and thank you very much for, for all of those that are answering and have answered. And the numbers are, I have to say, are somewhat, again, I'm not going to say confusing, but I'm just going to end the poll. But kind of consider this. I'm happy to say that none of you basically said, I don't consider this to be, so bad. So that's a good thing. So it means that you guys are already thinking, already doing something about it. The first step is kind of knowing, we've spoken about the visibility. We've spoken about the fact that, you guys are here. It means that it is something that is on your plates. But over 50% of you basically said that you're either somewhat confident or not confident at all. So it will be interesting to kind of see, because we are, as I said, going to dig a little deeper and kind of show you Pentera's approach and how we go about this, and we're going to go into some of the details. But let's kind of continue and kind of keep those in mind, and we'll refer back to those in a few minutes. Let me kind of close this for a second. Okay, so as I said, let's bring it down to earth with a real kind of world example. And what I want to talk to you about is the Mercedes-Benz GitHub token issue. And this whole thing, as I said, started off about 2.5 years ago. And to me, this is like textbook of how, a misconfiguration or human error really exposed, or quietly, what I like to call snowball into a multi-dimensional security incident. And this kind of whole notion started because of a misconfigured token permission, and the exposure itself went unnoticed for 123 days. Now, think of that number again. It's not a 1 day, it's not a 2 day, it's not a couple of weeks, it's 123 days. It's a fairly long time, and it started off in September of 2023 and ended in January 24th of 2024, if I remember. But again, this wasn't a breach in the traditional sense. No perimeter was broken, no breach occurred, no stolen credentials. It was basically an exposed secret, the way we like to call it, pretty much left in plain sight, and something that can really easily slip through the cracks, slip through the, your existing tools. And, if you're not continuously testing and validating them, and if you're not looking into that specific issue in your kind of new attack surface, this is something that can really happen to pretty much everyone. And and here's the proof of that. Now, in this case, and we have to kind of bear in mind that GitHub repositories, often hold more than just source code. as you can imagine, they can contain API keys and access tokens and database credentials and blueprints. And, as we've seen here, and other internal documentation. It can be about, an IP, or it can be about an acquisition or a new technology. Just think of, kind of the repercussions that it may have. And in this case, as I said, the kind of the access or the token basically gave access to multiple private repositories, including, as we've said, vehicle design plans and, and other issues. So theoretically, an attacker, should they have access, could have, cloned those repositories. They could have inserted backdoors without even you knowing about it, or even exfiltrated, your proprietary or your IP, all without really triggering a single alarm, without really, tripping any wires or performing any of these things. So, when I think about it again, and we've spoken about this before, what does that tell you about either existing tools or existing capabilities, or even kind of the visibility that organizations kind of typically have as, as it relates to, that length of 120 plus days?
So in the pipeline of the CI/CD or the deployment of the code, it's really hard to understand that there is something that is being leaked outside, even if there are, certain guidelines of healthy code development, like code reviews and things like that, that provides another set of eyes into the code that I'm providing or that I'm developing. It's still something that eventually the human factor, the human vulnerability still exists there. No matter how much we will try to understand this technology that needs to be defense, the problem is not the technology. The problem is the humans, is the developers, is the people that wants to upload their project, their scripts, maybe as part of the company, maybe as a side project in the company. But eventually, if things are being exposed outside, they are left there almost forever. And we will see how it can be remediated and fixed later.
So you're basically saying we can't just rely on the people, and kind of our nature as human beings. We are kind of lazy with using or reusing passwords and so on and so forth. So you're saying kind of you need that automation, you need that validation, you need to perform that on an ongoing, continuous basis and at scale. That makes perfect sense.
There are a lot of defenses that you can do. You can learn and you can train the people, the employees, of how to do a healthy code development, but still you need the other side of the coin to understand what attacker can see, and we need to validate this.
Nice. So let's kind of think of and you've spoken about the other side of the coin. So one of the other things that that we've seen, it isn't just, and again, because of the fact that no human beings were harmed in the making, if you will, or no animals were harmed in the making. In this case, this didn't have, a direct implication on Mercedes. The only implication that they had is on the sense of, kind of GDPR and a compliance or regulatory aspect. So under GDPR, as you can imagine, kind of exposed credentials or anything like that leading to unauthorized access are required, or kind of must be reported, if you will. And failure to do this will result in regulatory scrutiny and fines and so on and so forth. But again, think of 123 days. Kind of it raises a lot of questions around their incident detection capabilities and basically their risk governance. I think that that's kind of a major thing that they kind of took to heart, and think that they kind of they looked inside hard and deep and said, okay, what it is that we've done, how could this have led to other issues. And again, if we're looking at other studies that have been done, and it shows that over 70% of consumers have basically said that they would stop doing business with a company that had a data breach. So let that sink for a second. Over 3 out of the 4 people almost in this kind of session today would say, listen, if I would see something like this around Mercedes, it hurts the brand. It doesn't just hurt. I mean, forget the cybersecurity and the, kind of their innovation and everything that they brought. It basically kind of hurts the brand. So every time you see their brand, whether it's Toyota or Mercedes or Uber or any other company that took part or was kind of inadvertently exposed data, my data, our data, you're saying, you know what, I'll second think that decision, whether we do that or not. But again, let's kind of continue in that sense, and let's kind of look into, as we've said, look at the attacker's playbook. And as with everything, and I think attackers are kind of very good at identifying, kind of those little kind of breaches and those little cracks in everything. And once they do find it, they don't really wait around. Luckily for, for Mercedes, nothing happened, and, nothing apart from exposure of the data, no one has done anything, malicious with the data. But with attackers, or the playbook, if you will, of the attackers, they actually follow a very distinct set of, repeatable things that they do. And, to be honest, they do this disturbingly well. And we're seeing that kind of happen or occur again and again and again. But we've tried to kind of unpack it. And Or and I had a multitude, again, of discussions with not just, kind of amongst ourselves, how we see this, but even with, with our customers. And they say, listen, it all starts with, with this. That's kind of that's how they view this. And that's pretty much the same way we're, as Pentera, kind of we are adopting and using that same mindset, that same methodology to really bring that, not just from a theoretical aspect, but also from, from a product-led kind of mentality, methodology, and Or will go into more details. So again, I hate to say this, but we try to break it into, 3 simple steps. The first is reconnaissance. Again, it's kind of that understanding. We'll break that down in a second again, but understanding, kind of the repository, finding the repository and scanning it for secrets. Remember, we said it can be tokens, it can be credentials, it can be API keys, it can be any sort of, any sort of information that you as the organization deem as, as something that you protect, your intellectual property or any other. The second would be harvesting. And again, the notion of kind of using those credentials, using that piece of information, that token, that piece of credential to move laterally. And it's not just for the sake of what information can I gather or understand, but really to progress within the infrastructure and attempt to kind of make my foothold within the infrastructure more persistent, more kind of stealthy. So looking into additional tools, looking into CI/CD workflows, looking into cloud services. The idea, the notion is to expand and kind of grow your access within the existing infrastructure. The third one is obviously exploitation. It's the persistence, it's the data exfiltration. And, I think kind of the most important one is kind of the persistence element. It's kind of that remaining undetected, what we like to call kind of blending in as a legitimate user. And that's exactly the notion of what happened or what could have happened in the Mercedes-Benz attack. So let's kind of, unpack those in more details and kind of go into more examples. So as we've said, initial step is reconnaissance. So in this case, just like we've seen here, attackers will use, whatever public information is out there and kind of search techniques across, GitHub accounts connected to your organization. It can be ones that you're officially tracking, or even ones who are, just like Or mentioned, and we'll see some examples, even historical data, things that you may have thought that, are purged, are no longer accessible, or no longer visible, but GitHub, just like everything else on the internet, pretty much remains there pretty much forever. So even if it's a piece of history, even something that you've committed as code and you think, oh, it's no longer there, it may still there. So they will look, again, attackers will look at your blog posts, blog links, email domains, anything that you use to commit code or source code into GitHub, or even kind of, mentions of the organization. And once they find a match, they start building the, kind of the attack. They start building the attack, the blueprint of the organization. As we've said, they look into the repositories, active or abandoned or historical data, and basically scan them for any clues. And between us, there are tools that do that automatically. They don't need to create the wheel. Pretty much like anything today, obviously with AI and other capabilities, that can be done fairly simply in an automated manner. And from it, expose or kind of gather secrets, credentials, config files, anything that you can imagine. And again, from here, once they have the blueprints, it's just a matter of kind of deciding on what is my next step. And typically, the next step is, again, we've said that before, harvesting credentials. What does that entail? It basically says, let's look at the APIs. It can be, Swagger, API files, understanding how your services communicate, whether it's, kind of human or non-human identities, how they communicate services within the organization, looking at CI/CD platforms like GitHub Actions or Jenkins, and kind of going from there and, kind of broadening their permissions. And again, the dangerous part is now they have these permissive identities or permissive roles. They can, as we've said, trigger deployment, inject code, pivot into your cloud or on-prem environments, and from there expand and broaden their attack. And as we've said, the last phase, before I hand it over to all, is kind of the persistence. That is the lateral movement, the persistence, kind of what they do or what they can achieve should they, have that persistence in your across your infrastructure. It could be exfiltration, as we've said. It could be pulling down files from your S3 buckets. It could be your Azure blobs. It can be archives, and everything happens silently because of the fact that they use legitimate credentials, legitimate users, or valid. Nothing seems out of place, unless you have a very good kind of anomaly behavior or anomaly analysis behavior in your infrastructure. It may be unlikely that you're kind of, you're missing that, missing that operation from happening. And again, remember the 120 days, 123 days actually number. That's exactly what can happen. You don't need those 123 days. Typically, that happens fairly quickly, and from that point of exposure until someone closes the tap and says, you know what, let's close that exploitability or let's close that exposure, there is a fairly long time and a time gap that needs to happen. So with that, I'd like to hand it over to all, and I'll stop sharing now. So all, you can kind of take it away from here and really show us, the mind change or the phase that organizations need to take and kind of go from just the discovery and understanding from a theoretical level into the actual validation. And how do you actually go and do this, not as a one-off experiment, but as something that happens, as we've said, continuously, automatically, at scale. So with that, I'll hand it over to you.
Correct, Asaf, and I will show you how we took this attacker perspective, what you showed us right now, the playbook of the attacker, and how we are going to, and how we are automating this in Pentera. But let's talk about the discovery and validate of those managed code repositories, and I want to separate between those two terms. There is the discovery and there is the validation. Like we said before, discovery is the visibility, to know that there are out there Git repositories, that they exist, and we can, we as a company that owns these Git repositories, we know that they exist, we can monitor them, we can perhaps take them down because maybe it's a project that no longer exists and we don't want them, the code to be exposed or to be exist anymore. And this is a huge part of the understanding. This is the starting point of the validation. And there is the validation itself, which is to, once we know that there is an existing Git repository, then we can check the security on top of that. We can validate that this repository is healthy, does not expose anything that we don't want to, especially credentials and APIs, and there is no misconfigurations. Maybe it's accidentally publicly accessible while we need it to make it private, because the thing that separate between a public repository and a private repository is a single checkbox when you are uploading this or you're deciding about the Git repository. Let's start with how we are going to discover it. And like you said, and like everything, we will split it into 3 steps. The first one is to discover a repository, or let's take it a step higher. The repositories themselves are relying or existing as part of an account. So we need to understand how we are discovering the accounts itself, the potential account that has all of these repositories. The next thing is to have to understand what is the account that I found. Is it really related to my company? Maybe it's something else. We will see an example of that. And last but not least, when we understand that there is a true account that related to our to my company, to our company, we need to extract the repositories, and this is the end of the discovery section. Now, luckily, there are, and we will see here an example of all of the following examples will based on GitHub. Luckily, those platforms are making it easy, also for not only for us, but also for attackers. We can apply something that is called GitHub docking, which is to apply some certain search techniques, sophisticated ones, to be able to get results of what we want to search. So here, for example, we can easily search for a type organization, which means it will be a repository that related to an organization, and that includes Pentera. by the way, we discovered that we need to understand how this search working, because if we will search Pentera.io, it won't yield any results, only the Pentera, for example, our domain. And then once we are getting all of the results of the accounts, like, are they all related to my organization? Not at all. We see here, because I'm from Pentera also, I know that only the first and the third here related to Pentera, to my company. But the second and the fourth, for example, the fourth here is Pentera Act Studios. There is nothing related to Pentera here. So we need to have the ability to filter them out. And this is what we are calling the ownership layer. We know automatically to detect if a certain account is related to the company, to our customer or not. And how we are doing that using data that exists out there in the account itself. It can be simple things like the account email or the account blog, like we can see here. The Pentera.io is a blog in the GitHub account, but sometimes it's missing, and we need to apply some interesting techniques like check the logo similarity, or maybe to check the people that contributed to the repositories inside. And if we see something, people that is from the company, from the organization that we are searching, then it provides us a certain confidence that this account related to our company, to the customer company. And once we understand that the account related to the company, we can fetch the repositories and show it to our customers. This is an example from the Surface platform. We see here all of the assets that we found, like domains, subdomains, IP addresses, websites, and a new one that we introduced following this feature in the last month, which is the code repositories. We can see here the name of the code repositories. We can see the platform. We can see the owner, who is the owner, who is the account that this repository exists in. And we also see when it was last updated, because maybe the visibility itself, like I said before, if there is an old repository that updated 10 years ago, why not to just delete it and not keep it up to the public, to the whole internet. And now here, there is a second poll question.
Excellent. So we've seen the first one, and we've seen the results that you guys provided. The next one we want to ask is, which of, kind of on the back of what all just presented, is how many of those code repositories, do you guys own?
Now I will share how much. Yeah, now I will share how much we have found from our customers, and then Asaf will share his results. We see here that we have, based on our customers, we have 15% of them have at least one GitHub account. But again, it's at least one. For each account that they own, or for each customer that own GitHub accounts, we have 1.4 GitHub accounts per customer. So if customers or organizations we discover in more than one Git repository, why is that? And the answer is because there are many other departments, many departments around the world for enterprises that can just create a new GitHub account. And this is very easy to create a GitHub account, by the way. It's just to log in into GitHub using my Google account and create a new repository, and that's it. I have a new account with an existing repository. It's very easy, very simple. But the interesting number here I want to pinpoint is the code repositories per customer. So here we have 14 Git repositories per each customer of Surface, but actually this is the average. There are customers with 5, and there are also customers with tens of code repositories. How they manage those repositories and how they maintain them and how they are validating the security on top of them, it's really hard to do so when you are working in a manual process and not in automated way.
And by the way, when I looked at the poll, I think we had a bit of a mix-up with the actual question that we asked. But funnily enough, we actually asked everyone on the line is, which of the kind of, the if you will, the secrets or kind of in terms of when they think of publicly exposed Git repositories, any code repositories, which of the information that sits there is their biggest concern. And you'll be surprised that over 80% of the people basically spoke of secrets and credentials. So some did mention they spoke of third-party risk. Obviously that's obvious. And I think an interesting one, which kind of ties up with what we've said about the Mercedes-Benz attack, is the fact of loss of brand trust or reputation. So it's a mixed bag. Even though over 80%, as I said, of the people spoken about, and we know that for fact. And again, kind of the leaked credentials or the secrets is a major issue and a major concern. I just want to kind of to tie that in as we kind of continue talking about this, because it kind of really ties in with kind of the accounts per customer. So just think of the repercussions should those credentials or leaked secrets kind of be exposed out there, and how much of that exposure is kind of directly or indirectly related to the organization. So I just kind of wanted to throw that in.
Definitely. As a security operator, my concern is that there are leaked APIs and secrets out there in the Git repositories. But as a C-level or maybe a manager in the organization, I really take care about the reputation of the company, of the brand. And this is two different risks relying on the same issue.
Absolutely.
So let's see how Pentera provides this understanding of the discovery. We can see here that we are starting from the domain. And again, everything here is automated. All we know is the domain of our customer. Starting from the domain, we are discovering potential GitHub accounts like we saw before. We are using several techniques like the GitHub docking. Then we are filtering the results based on the blog, like we see here. Maybe it's the people that contributed or the logo similarity. And then when we are filtering the results with only what is really relevant to our customers, the customer, we getting the specific GitHub repository that we want to validate the security on that. And again, we have 3 steps of how to validate those repositories. First, it's not just the code that exists. It's not this file or that file. It's everything. When you are working in a Git environment, there are lots of data points, lots of insights that you need to put. For example, what about the commit text that you are providing? What about not the code files, but some configuration files or other files and data points that can expose certain secrets and APIs that you don't want them to be exposed. Second is once we know all of the items in the object, we can discover secrets. We can go one by one and understand using different techniques again to see how many secrets exposed out there. We right now supporting more than 700 detections of secrets for different vendors like GCP, AWS, Azure, of course, those are the big 3 clouds, but other third-party services like Atlassian, Figma, and everything that you can think of, probably. And the next phase here is the actual risk of the validation. We can take those secrets and API creds that exist and validate them against the relevant service. So if we find an AWS key and an AWS access key and access key ID, we can take those 2 data to leaked credentials, and together we can check if those are valid against AWS. And by doing so, we are providing a real value and real understanding of the risk that currently exposed, not what happened before a month ago, but right now still risk the customer and still provides and still needs to be remediated. Now in Pentera, we see that the validation part, we see again here, we have the vulnerability, which is the API secret that is exposed in the public code repository. And this led to us to found an API secret, right? And then we have the last part here, which is the validation itself. So after we find the secret itself, we are validating it against the right service. And the full vector looks like that, starting from the discovery. And again, everything here is automated, starting from the discovery side, going into the validation, raising this vulnerability that you need to remediate, and ends with the actual understanding of the risk that sometimes they won't be validated, right? Sometimes it's an really old keys and credentials that were exist out there, but they are no longer valid. But still, the understanding that there were a certain credentials exist out there, it's still important to understand it, because it means that the security aspects around there are not so much as good as needed. And this is an example. So we see here a commit file. This is from 2023, right? And this file, by the way, no longer exists. If you will go into this repository, we see that in the master or the main branch, it no longer exists. But in the commit file, a few years ago, it was exist. And we see here an example of a test function with a private key, which is really big no-no to provide here a valid key. And of course, to provide here test functions with real values, it's something that not provides any helpful actions, and it's not really the right approach of providing here and committing the files. And also more simple one, the right away the .env file, which is a file that exists to save some environment variables. Here we see an environment variables for a certain tool with the full key exist out there. So why can't we just take this key and check against the relevant service and see if it's still valid or not? And many services, by the way, providing keys for a long time. So in lots of cases, the existing API keys will be still valid for a long time. And like you said, 5 years it was exposed and was still valid. So what you need to do when you are encountering this situation? First of all, you need to revoke and rotate this API or these credentials. You don't want them to be validated. You don't want them to be used. Maybe they can exist there for a certain time, but you don't want them to be any more valid, so attackers won't be able to infiltrate and to get this initial access to other services. Then you want to make sure that this repository is private and not a public, of course. Later, you can go to the development team and ask to purge these commit files and to clean the history. So there, all the other data points that, like I said before, that we are enumerating everything, so there will be nothing exist. So this API key, our credentials, will be gone. And last but not least, there are lots of other people that can fork your Git repositories. So you want to make sure that they will do the same action. They want them to pull the latest, update the latest version, so your credentials won't appear in their repository, which is some of our like a third party or a supply chain attack that can happen later following to that. So what are our final recommendations, Saf?
Thank you all. So, by the way, we did get quite a few questions from you guys during the session. I have jotted down some of them, but let me, before we answer them or answer some of them, because I know that we are likely short on time. Let me kind of give you, again, our 3 cents, if you will, on how we kind of see this moving forward. So we spoke about the issues. If you remember, initially we spoke about the visibility, the attack surface, and the context. So I want to kind of bring it down, or kind of bring it down to earth, and kind of really give you our recommendations, if you will, in terms of the real recommendations, kind of the real life recommendations. So the first one, it's kind of obvious, but really start with with visibility, and that's pretty much a good basic practice for everything. And all spoke about kind of best practices when you build your SDLC, your software development lifecycle, and that pretty much applies everywhere there. So kind of get a really good understanding of your assets, of your attack surface, be it on-prem, cloud. We mentioned third party. You also mentioned that as an issue when when we asked you the second question. So as we've said, start with visibility, start with an understanding, mapping, kind of the lay of the land, understand where your attack surface and where exposure may lie, and start with there. Once you have that, start understanding and assessing and testing the risk. It means kind of look at the risk that each asset may pose, and there may be some dependencies that you're unlikely aware of. And again, maybe you're using someone else's commit, maybe you're using an old or historical piece of data that you're not the owner of, but that information may include private information or public keys or API keys or any sort of credentials that you may not necessarily be aware of. So get an understanding of that, assess the risk of each asset, as we've said, obviously including, public code repositories. So that would give you kind of, a kind of a second layer, if you want, on the initial visibility. And the third one, we've spoken of context, but context, on its own is good, but how do you kind of go about fixing it? Kind of eliminating, minimizing the attack surface, minimizing your risk over time on an ongoing basis. So in order to do that, you need to have the context, but for fixing or for managing or mitigating the risk, you need to get that context. So fix the misconfigurations, look at the vulnerabilities before they become, as it says here, before they become the next breach, before they become the next headline. So that's the notion. You need to have that context in order to have, the confidence to go about, fixing those or remediating those risks. And as I said, we do have a couple of questions. So if you don't mind, I'll read out some of them to you, and we can decide. I think we have probably 3, 4, 5 minutes. So let's try to to get potentially the 2 big ones out of the 6 that we've received. So the first one is a big one and a really important one, and I think that it really merits a longer discussion, but we'll try to kind of answer this as quickly as possible. So when you think of Pentera's solution, how is that different from your run-of-the-mill secret scanning tools we already use as an organization or as in GitHub?
So first of all, we have the two kinds of the actions we do. First is the discovery one, and the next is the validation one. And the discovery one is very hard to do so. There are, like I said, automated tools that maybe only doing the discovery, but are not doing the validation. Or maybe there are tools that are doing only the validation, but you need to feed them with what you have. And like we said, you don't know always what you have. And to do that in an automated way, it's very important to understand it and to maintain the security and the Git repositories as needed.
Nice. So you're basically saying it's if you want to compare this to, I don't know, to a vulnerability management tool or something like that, or a patch management, you're saying it's, they kind of go this far. They would give you a very good understanding of your assets, of the risk, but again, it may be more of a theoretical risk versus true real validation that happens on an ongoing continuous basis. It makes perfect sense. The second one that I would like to kind of to discuss is, and again, I think it's a very important one, is how do you determine if an exposed credential, and a lot of you, as I said, 80% of you mentioned credential as as a main attack path, or as as something that they deem as super critical. So how do you determine if an exposed credential is truly exploitable or just noise?
There is only one solution for that. You just need to try. You just need to take this API. You need to know to which service this is related to, which this service provided this API key or credentials, and only by to understand that, you can then check and test yourself if this is still valid to this service. But sometimes it's not so much easy, because you can't just go into let's say Figma and just provide them their API that you saw, and they will tell you, oh, this is ours, this is not ours. It's very hard to do so. You need to know how to communicate with this service. There are certain APIs, proprietary APIs, for each and every service that exists out there. So the only way to do so is to test, to understand if it's really exposed and if it's really in risk. Maybe you can go into the configurations or to the settings, as maybe you will see a certain key, but sometimes what you see is not what the other people that generated this key sees. There are some privacy actions, there are some other types. Like I said, each service with its own proprietary API and process of how to generate APIs. So you need something, and you need a certain tool. You need to know how to validate that a certain key is really related and validating successfully to the service that you are searching.
Makes perfect sense. So basically kind of tying that back with what you said around validation. So unfortunately, I think we're getting towards the end of our time. So first of all, as I said, we do have additional questions that we will answer, all of you, if you will, directly, or people who've answered or requested the questions, and we'll make sure to reach out back to you. So I would like to kind of wrap it up with that and kind of basically say that for those interested, we are hosting at Black Hat, which is happening in August. Pretty much the banging party, kind of the biggest and most exciting party, in town during the week of Black Hat, as I said. So for those interested, scan the code, register. If you're in town, happy to to catch you in our booth at Black Hat, or better yet, scan this one and get an entrance to probably the wildest and best party in town during Black Hat. And with that, I'd like to thank you all, for joining, and see you in our next CyberPulse session. And with that, any final words?
Just be careful and continue to validate.
Excellent. Thank you very much. Thank you, everyone.
Thank you, everyone.